Okay, class, remember the last class, the last session we learned about how to calculate the pressure difference between point A to point B. Okay, this is just a recap. Alright. So basically, this is how to calculate. You need to find the reference line, okay, and then set the direction where you want to measure from A until B. Okay, and then this is example we have done so far. Okay, so that means in general, what we have learned during our last session, basically on measurement of pressure. All right, we measure the pressure difference between point 1 to point 2. Okay, so for today's session, we will cover the hydrostatic force on plane surfaces. Alright, so what it means. Alright, for example, we have the straight plane. Okay, we have a plane submerged in the water. We will have the variation of pressure. So,
excuse me, doctor.
yes.
I don't know if it's me or it's your share screen, but it's not clear.
Is it not clear?
The share screen.
No, it's clear, doctor.
Oh, then it's me. Sorry.
Okay, is it clear now?
I think it's a bug,
Okay.
doctor. Some student got the screen not clear. Yeah, but some of us still clear. I think it's a bug.
Oh, then never mind. I will just close and rejoin again.
Okay.
Doctor, I also.
Are you able? Some of you got clear sounds, right?
Yeah, it just need to rejoin to make it clear, doctor, if it not clear.
Okay. Please do. Right. So let's proceed. Hydrostatic forces on plane surfaces. So when the fluid at rest, okay, as I mentioned before, it has no motion at all. Okay, no motion, no tangential or shear forces. That means there is no shear stress. Number two, normal forces exist. Alright, this is the fluid. The normal forces always act perpendicular to the surface. Okay, and then have normal stress, which is a pressure. Right, so the pressure here is a force. Okay, which is F equal to P over area. So if surface is present, all forces are normal to the surface. For example, if this is surface, all the normal force must be perpendicular to the surface. If pressure is uniform, distributed over an area, this is the consequences. Alright, the first one, force equal pressure times area. This is normal, yeah. And then point of application of force is at the area centroid location. Alright, I will later explain about this part. The force is at the area centroid location. This you will learn later on. Pressure is uniform of submerged horizontal area. If in gases, pressure variation in vertical direction is very small. Okay, this is only for gas, very small for the pressure variation. However, for the liquid, we need to further analyze because pressure is jet. Yes.
I want to ask the sentence that say the force equal to pressure times area, or force equal to pressure over area.
Pressure. Okay, sorry. Force equal to pressure. Okay, this is not okay. Thank you. This is typo. This is divide. Okay, divide with area. Okay, thank you. Alright. Okay, for liquid, we need further analyze because pressure is generally not uniform as you move in a vertical direction. So that means if you move from vertical direction, the pressure will not uniform. That is why you need to analyze the vertical forces on the plane. Okay, so let's consider a vertical plane. Okay, for example, we have the vertical plane. Okay, this is a plane submerged in the water, right? And then this is a water, right? Let's say this is water. Okay, so what happened? Basically, we have forces acting on the plane. So what the forces involved? We have pressure force. Okay, this is the force distribution. Okay, as you can see, the pressure, all right, this is the force. Okay, the pressure force. So as you can see, the pressure force increasing with depth. Remember previously we derived the hydrostatic equation. Hydrostatic equation, which is P2 minus P1 equal to negative rho G Z2 minus Z1. Okay, so here increasing in depth from here, okay, will increase the pressure. So the negative signs mean it is negative direction. All right. So from here, what I would like to highlight on this point number 2, which is point of application force, is the area of centroid location. Okay. So from here, you can see we have the distribution of force. So it's difficult for us to calculate one by one. So definitely we're going to find the resultant force. So how to locate the resultant force? Okay, the location of the resultant force basically at this location. Let me use at this location. This is we call as resultant force, right? The resultant, the combination from here until here. So, and then imagine that this is the plane, all right? This is the plane. When we look from this side, this is our eye. What happened to our dimension? What happened to the plane dimension? Definitely we're gonna see like this, right? Okay, this is from this side. When we look at from here, this is the plane. When we look at, this is our plane. So this plane will have the centroid. So definitely the centroid will be located at the middle. Okay, this is what we call as a centroid. Centroid of area. Different area will have different centroid. So from here, directly translate into here. So let's put here X. Okay, this is centroid. So let's rename here from the surface of the water to the centroid is HC. Okay, from the surface to the resultant force, okay, is HP. Okay, so far right now you need to understand this concept first. Okay, do you have any questions so far, class?
No, doctor.
Okay, okay, nice. So consider, so this one we have no angle. It is vertically. Okay, it is vertically 90 degree. So what happened when we incline the plane inside the water? So this is second condition. So let's draw a plane here. All right, and then this is the water surface. Okay, so from here to here, let's say we have angle theta, right? And then we need to define this, the coordination. Okay, coordinate. So let's say this one. Okay, this one. Let's say this one. Okay. Let's say this is our coordinate. Yeah, this is y. Okay, this is in the y direction lah. And this is the x direction. Okay, or better like this. Okay, the y direction. So from here, okay, let's say this is 0. So from here to here, let's say this is, okay, okay, let's say from here is here, let's say it is y, the change of y. That means y can be in any direction, sorry, can be in any point. Maybe it can this point or this point, right? So when we look at here, okay, from our eyes, definitely this is the plane. All right, as I mentioned before, we look at eyes, we can see this is the plane. And the plane will have the centroid of area. This is x. So where's the centroid? Definitely this is the location. Okay. So from here to here, okay, is the YC. Alright, the centroid at Y location, at Y direction. And then definitely we have the force. Okay, this is the force. Remember that the force always act perpendicular to the plane. So where do you think the resultant force act? Is it at A, or is it at B, or is it at C? What do you think? The resultant force?
A.
A, definitely. Yes. The resultant force will act at A. So this is F R. Okay, it will not, remember, it will not act at the centroid. So from here to here, we call as a YP. Okay, the center of pressure. So how to derive this carefully? Okay, so since we know that the pressure is equal to force over area. Okay, so sorry, I think I mistake this one. This is not the force. This is pressure, force over area. Okay, this is correct lah, yeah. Okay, pressure, force over area. This is correct. Okay, so pressure, force over area. So let's take a look about the derivation. Okay, since this is considered as the small element, so the differentiation of force, that means the small force acting at the small area. Okay, this is the basic, yeah. Okay, we want to know the integration of the whole force acting at the area. So this is force equal to P multiplied with A. So the change here is basically the area. Okay, increasing the area will increase the force. Okay, so where pressure equal to rho GH, or rho G is simply gamma H. Okay, and from here I want to change H in terms of y sine theta. Okay, so where is the H? Okay, this is the H. I want to show you where is the H. Okay, from here to here, basically this is H. Okay, because H is vertical. Alright, y can be in their coordinate system. Okay, make sure H is from the top surface to the bottom. It is vertical direction. So from here to here, basically H C. Same goes here. From here to here is HP. Right? So in order to convert from okay, H to Y, you can see in order to get H, Y sine theta, you will get H. Okay,
I have a
so
question,
from
Doctor.
here, yes,
What if the plane is out of the water?
okay, out of water, we consider only the plane inside the water. Okay, for example, we have the plane here, right? So remember that we must start the origin at the surface of the water. Okay, so that means we can remove this one. Okay, clear?
Okay, Doctor. Thank you.
Okay, good question. And then substitute into the equation D F equal to P dA. So I want to substitute pressure into this one. Okay, so gamma H dA. Gamma H dA, I try to substitute H with Y sine theta. So gamma Y sine theta dA. Okay, so from here, okay, we try to do the integration. Integrate. So once you do the integration, meet the differentiation, it will cancel out. So only left F, the resultant force. Okay, this is the constant. The constant we can put outside, gamma sine theta integration y dA. Okay, so y is constant or not? Y is not constant because you can see it keep changing the variable. Okay, y can be 1, 2, 3. dA definitely the change in area. So do you know that the integration of y dA basically is the first moment of area? Okay, I want to ask you, what is the purpose of first moment of area introduced by scientists? I believe you learned this during statistic, right? No, static. What the purpose of first moment of area? Anyone know? What's the purpose of first moment of area? Okay, it's okay. The first moment of area is used to find the centroid of the area. For example, if this is the area, you can know directly this is centroid. How about this one? Do you know the centroid? You might not know. Maybe this one centroid, maybe this centroid. So that is why the first moment of area is introduced to find the centroid of this location. Maybe this centroid. Okay. Alright. It is used to find the centroid. So once you look at the formula, okay, it will be like this. The resultant force is equal to gamma sine theta. This y will be yc, centroid. Okay, remember it is used to find the centroid. That is why it is replaced with yc. So yc basically the distance to centroid of the area in contact with fluid. Alright, remember that we only consider the plane in contact with the fluid, which is submerged in the water, not outside the water. Alright, so okay, so from here, okay, okay, let me draw you the triangle. Okay, this is the theta. Remember that this is HC and this is translate to YC. So in order to get the HC, basically YC sine theta. Okay. So I want to replace this one, YC sine theta, we can be F equal to gamma HC A. Okay. Or PCA. Because pressure equal to gamma times HC. Okay, basically this is the final equation in order to find the resultant force acting on the surface, okay, plane surface. Okay, so once we know the magnitude of the resultant force, which is gamma HC multiplied with the total area, how about the direction? Where is the location? Since we know that the FR, the magnitude, we know the value, we know the magnitude. However, we must know the location because this is vector. We must have the magnitude and direction. So the magnitude we already derived. However, we need to find the location. So here we call as center of pressure. So you can see here, the force here acting on the center of pressure. This is we call as a YP. So how to calculate the YP? Okay, this is YP. Okay, for example, from here to here, this is HP. So how to calculate the HP or YP? Any idea? Alright, this is basically the faster one. Okay, in order to get the YP, we're gonna use the equation. Okay, this is the center of pressure where point of resultant pressure force act on the submerged area. So can use the pressure prism to find the resultant pressure force. Okay, this is the step lah, find the volume of submerged shape and line of action. To find the coordinate center of pressure, we use this formula. Okay. Y or capital Y, you can use YCP equal to negative IXX, okay, sine theta over with HCA. Okay, this is the Y direction. However, if you want to locate in the X direction, XCP equal to negative IXY sine theta, okay, over with HCA. Okay, this is the direction. Okay, for example, this is the coordinate. This is Y and this is X. Refer to this one. Okay, so with some moment of the element, elemental force, which is PdA about the central. Okay, and equate it to moment of resultant force. Okay, basically this is just a definition to derive this one. Okay, so what you need to know basically this equation. Just remember YCP equal to negative IXX sine theta over HC time area. Okay, later on I will explain this term. Okay, IXX or IXY are found in table. Okay, I will show you the table later on. So this theta is the angle between, now this is very important, we have the theta here, angle between the plane, surface and horizontal. Okay, okay, so this is the plane surface to the horizontal, this is the theta. Okay, so let's recap for what we have learned. Okay, now go to menti.com. I will share you the code. Okay, Mentimeter. Okay, let's have a quiz here. Okay, class, please go to menti.com. And use the code 148611515. Okay, let's see who will be the winner for this section. Okay, we have 51 students now. Okay, let's start our first question. Okay, get ready, yeah. Please faster join the session, join the menti.com. Okay. Answer fast to get more points. So barometer measure what? Okay, 3, 2, 1. Times up. Okay, it is not normal. It is barometer measure absolute pressure of atmosphere. Okay, let's see who will be the first leaderboard. Okay, we have a Naruto fan here. A. Okay, good. Okay, next question, please. Okay, manometer consists of what? Okay, consists of what? Maybe there could be two question, two answer. Manometer consists of one or more fluid and made of glass and plastic U-tube. Alright. Okay, we have SR. Okay, Tembam the faster one. Okay, excellent. Good. We have Noha as well. Okay, the first step to solve the manometer question is how. Remember our first step to specify what, to identify what. I hope you get all this right, yeah. Yes, majority of you right. Specify the reference line first. Okay, let's see the faster and the top ranking here. We have Hafizul, Samuel, Noha. Noha always okay. Noha, Gaga, Fadil. Okay. Okay, number 4 question, please. Okay. Okay, good job. Okay, nice. We have okay, Tembam still the ranking number 1. Okay, good. Okay, Noha already top 11. Okay, finally, we want to see who will be the winner. Get ready, everyone. Center of pressure is basically of what? What is the center of pressure? HP or YP? Okay, this is what we learn, yeah? Okay, resultant pressure force. Alright, it is resultant. Alright. let's see. Oh my God. Okay, congratulations. Please introduce yourself and your strategy.
Hello, Doktor.
Okay, what's your name and your section, please?
Nur Muhammad.
Okay, Muhammad, is it?
Nur Muhammad, section 13.
Nur Muhammad.
Muhammad.
Tak clear lah. Can you repeat?
Nur
Nur
Muhammad bin
Muhammad.
Azman.
Sekejap, tak dengar. What?
Saya ni, doktor saya sini tak clear. Saya
Okay.
lain memang tak clear.
Okay, section,
Section 13.
nama,
Nur Muhammad.
NUR.
Ya saya.
NUR.
Okay, I will check, yeah. Okay, what's your strategy?
Ha?
What's your
Saya
strategy? Concentrate in the
Saya
class.
jawab.
Concentrate in the class
Saya
only.
jawab doktor.
Okay, congratulations Nur Muhammad from section 13, good job. Okay, class, please follow the example. Okay, Nur Muhammad, concentrate in the class as well as you need to concentrate during the quiz time. Okay, let's take a look about this one example. Okay, and then we end our session. Okay, for example, a door with 1.2 meter long and 0.8 meter into the pitch. Find the force F on the gate and its center of pressure position X. Neglect atmospheric pressure. Alright, for example, we have the diagram. This is a diagram. Okay. And then we have the plate. We have the door. Okay. Alright, this is the angle. Okay. So, let's say the angle is 40 degree. And this is the dimension, which is from here to here is 1.2. Okay, 1.2 meter. And then 0.8 is into the pitch. So from here to here is 4 meter. Okay. Alright, and then we have here, this is oil. Okay, this is oil. Speed specific gravity of oil is 0.82. Okay, and then this is the dimension 6 meter, and this is 8 meter. From here to here, basically it is 1 meter. Alright, and then where is the force? Okay, this is the plane. This is the centroid, yeah. So definitely the resultant force acting below the centroid. Sekejap, saya ada cakap. Nanti saya tak bawa. Yang saya
patut host ada dekat sini kan? Ada.
Host dekat atas.
Teknikal, semua kat atas.
Semua kat atas.
Patut dia bukan kat bilik fizikal kalau apa isu.
Depan pukul 11. Depan pukul 11.
Technical host. Bawah ada.
Teknik lepas pukul 11 baru dia akan pergi semua dekat
Physical.
physical.
Oh, bagus kelas.
Okay. Sorry ya. Okay, so this one.
Ada physical check tak ada?
Tak ada lagi. Semua kat atas. Okay, this is the resultant force. FR. So, our first step, we need to calculate the force P. which is this one. So how to calculate this one? Use our equation. F equal to gamma HCA. This is what we derived before, yeah. So our difficulty here is HC. How to find the HC? So HC is basically the centroid of location. Okay, the height of the centroid to the surface. So how to get the HC? Okay, any idea? This is the reference line, and this is HC. How to get HC? So HC basically the combination of 4 here. Okay, 4 meter, we need to plus with this one. This dimension. Okay, so how to calculate this dimension? How to calculate this length? Any idea? Which is 1 from here to here is 1. We need to plus with this one. What is the value here? This is half from 1.2, which is 0.6. Okay, so bracket 1 plus 0.6. Okay, we do the sign 40. Okay, in order to get this dimension, this length, sine 40. Okay, we will get this length and then plus with this length. Okay, so after calculate, we will get 5.028 meter. So we need to substitute the equation into H here. So F equal to gamma of oil. This is oil here. So in order to get gamma of oil, basically specific gravity of oil must multiply with gamma of water. Okay, gamma of water basically 9790. How I get this? Basically from here. Gamma equal to rho multiply with gravity. Gravity is 9.81 and rho is 1000. Maybe the rho is not exactly 1000 lah. It is 989 something lah. You multiply with this one, you will get this value. Okay, so for the time being, I'm going to use 9790. Okay, we need to find the exact density. Yeah, during your calculation, when the temperature is not given, yes, you can use 1000. Okay, clear, yeah. So 0.82 specific gravity multiply with the gamma of water 9790. Okay, multiply with the HC, which is 5.028, multiply with the area. So what's the area? Area of what? Area of the door, which is 1.2 multiply with 0.8. So you will get here 38749.2 Newton. Okay, so this is the magnitude. However, the last question, we need to find the pressure position, which is this one. This is very important. We need to find this location. How to get this location? Okay, so first we need to set the axis. This is y. Okay, this is y and this is x. So I'm going to use YCP. Okay, because y-axis is parallel to the plane surface. Okay, so YCP, our initial equation, YCP E is equal to negative Ixx sine theta over with HC multiply with the area. So, how to get Ixx? Okay, when you look at the table, I don't have the table. When you look at the table, okay, the moment of area table Ixx, you will find that the Ixx for the shape of rectangular is basically Ixx is equal to BL or BH cube. BH cube over width 12. So where is the B and where is the H? Okay, remember that we have the longest one. The longest one should be referred to the H because this is how you remember, because this is the power of 3. The shortest one, it is the B. Okay. So, based on the dimension of the door, which is H equal to 1.2 meter and the B refer to the 0.8 meter, substitute in the equation 0.8 multiply with the H 1.2, the power of 3 over 12. Different geometry will have different Ixx here. For this one, it is rectangular. So you will find that the value of Ixx basically 0.1152, the unit of m, the power of 4. Okay, and then just substitute here, negative Ixx is 0.1152 sine 40 over with HC. HC we discover it is 5.028 multiply with the area of the door, which is 1.2 multiply with 0.8. And then the final answer should be negative 0.0153 meter. So, you discover that this value is negative. That means it is below the centroid. So, can you see it is C? So, C is centroid. So, CP. So, from here, okay, this is our centroid, right? Okay, this is our centroid. So, it is below the centroid is this value. So, I would like to draw again. This is our door. And then this is the centroid. And this is the resultant force. So, this is the length here. It is 0.0153 meter. So, how to calculate here? Okay. So, basically, okay, we have the centroid is, you can see 0.6. This from here to here is 0.6. How to calculate here? So definitely we need to plus. Okay. The location here, the centroid location, therefore x location is 0.6 plus 0.0153 meter. Okay. You will get the final answer 0.6153 meter, the location of resultant pressure. Okay, so let's take a look at the question. Okay, find at its center of pressure X. Okay, so you can say that it is 0.6153, the location of the pressure. Okay, from this one, from this surface of the from the door. Okay, if you are good enough, you can find H, what we call, if you are good enough, you can find the HP. Okay, how to get HP, which is HC. Okay, plus this one. Okay, so it is plus 1 plus 0.6153, and then you sign with 40, and then you will get the final answer. Okay, I think that's all. Any question, class? And, pardon, can you repeat the question, please?
No question.
Okay, is it clear, right? This is example I try to explain to you how to calculate the location of P as well as the magnitude of resultant force. Okay, I think that's all for today. Thank you very much for your time. Okay, after this, I hope that you study before the class and concentrate more on your exam. Okay, I think that's all. Thank you very much. I end my session with Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Okay.
Thank you so much, Doctor.
Thank you, Doctor.
Okay.
Thank you so much.
Thank you, Doctor. Waalaikumsalam. Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor. Thank you, Doctor. Thank